Morning everyone. I thought that I would make a little video to teach you a new formula. So I'm going to start off with stuff that you already know. If we had a quadratic, x squared minus 6x minus 10 equals 0, then you know that we can solve that using the quadratic formula. So we would get x equals minus b, 6, plus or minus the square root of b squared, 6 sixes are 36, minus 4 times a times, I'm sorry, I'm going to make that a plus, minus 4 times a times c would be 40, all over 2a, which is 2, equals 6, plus or minus the square root of 36 minus 40 is minus 4 over 2 equals 6. Plus or minus the square root of 4 is 2, and the square root of negative 1 is I, all over 2. And we can take 2 out as a common factor, and that would give us 3 plus or minus I. So the roots to that equation would be 3 plus I, or 3 minus I. And I want to stop here just for a minute to emphasize that the roots of a quadratic, if they're complex, are always conjugates. 3 plus I, 3 minus I, so these are conjugate pairs. And that's very important that you remember. If you know one of them, the other one is the conjugate. So hopefully you already knew that. So this next thing, you also should know. X equals 3, x equals 2. If they were the roots of a quadratic, then I could find out, going backwards, that the quadratic looked a little bit like this. And then I could expand that. X squared, I've got minus 2 and minus 3. X is minus 5x. Plus 6 equals 0. Also something that you should know. Okay, now I'm going to do something that's a little bit new. So that's finished. If I had a quadratic and the roots of that quadratic were unknown, but I'm going to call one of them alpha, and I'm going to call the other one beta. Then, using the same method, I could work backwards and say the quadratic must have been x minus alpha and x minus beta equals 0. And then I can expand that. X squared, that times that is minus x beta minus x alpha, and minus, a negative times a negative is a positive, alpha beta equals 0. Now the middle terms factorize because there's a minus here and a minus here. I can take that out. There's an x here and an x here. I'll take that out, but I'll write it after the bracket. And what's left is an alpha and a beta times x. So this is the coefficient of x plus alpha beta. Okay, now this is a new formula. Let's put a square around it. So this alpha plus beta is the sum, what you get when you add up the two roots, and this is the product of the roots, what you get when you multiply them together. So if I had applied that formula to this problem, then if I add them together, I get 5x, and there's a minus here, minus. If I add them together, I get minus 5x, and if I multiply them together, I get the 6. Now, you might think that this is easier than that, but now let's move to a question that has got complex roots. So if I start out with x equals 1 plus 3i as a root of a quadratic, then you should be able to tell me that the other root is going to be 1 minus 3i because they are conjugate pairs. And if I use this first method, this method that we had here, then I would have x minus the root, and the root, because I'm subtracting two terms, I'm going to put it in a bracket. And the next one, x minus the other root, also requires a bracket, equals 0. And then I can multiply this out, minus 1 minus 3i, and x minus 1, and the two negatives make a plus 3i. And now I have to expand this, so I'm going to multiply x times each of these terms. That will give me x squared minus x plus 3ix. I'm going to multiply the negative 1 or the minus 1 times each of these terms. Minus x plus 1 minus 3i. And I'm going to multiply the minus 3i times each of these terms. Minus 3ix. The negative and the negative make a plus 3i and minus 9i squared equals 0. That's horrible. Let's see what that simplifies down to. We've got an x squared. The minus x and the minus x makes a minus 2x. The 3ix and the minus 3ix cancel out. The minus 3i and the plus 3i cancel out. The I squared is negative 1, so minus 9 times negative 1 is plus 9, so we've got 9, and 1 is 10. Okay, so that's our quadratic. I think you would agree it's pretty ugly getting there. Now instead, let's use our new formula. So I'll write it down again for us. X squared minus the sum of the roots plus the product of the roots, with a minus sign out here. So here's our formula again. Need to learn it. And then the quadratic is going to be x squared minus, what do we get when we add together these two roots? So we've got 1 plus 3i plus 1 minus 3i. So the 1 and the 1 add together. And the 3i minus 3i is nothing. 0. And now I want the product of the two roots, so I'm going to multiply these two together. So let's do that over here. What do we get when we multiply 1 plus 3i and 1 minus 3i? That's 1. The middle terms cancel out, and we have minus 9i squared. This is negative 1, so that makes that 1 plus 9, which is 10. Which is 10. And so there we have the same solution, but I hope you will see that this is very much easier to use. So when you are given two roots of a quadratic, you can work out what that quadratic is by using the formula x squared minus, make sure you put a minus here, the sum of the roots, add the two roots together, x plus the product of the roots. Okay, I hope that's been helpful for you.